Hands are off and eyes are up. Today we're going to use our bar models to represent and solve some word problems. Look at the screen for our first problem. We're going to read this problem together.
What happened to the number?
When we see a box, we're just going to say sum, because we don't know what numbers there yet, right?
So we can make any sum we want?
We're just going to say the word sum. Ready? You're going to read with me and begin. Janelle's Market sells bags of some oranges. Simone needs some times that amount. How many oranges does Simone need? I want you to think about, what is this problem about? And what are we trying to find out? Talk at your tables. What is this problem about? What are we trying to find out? So what is the problem about? That's what we need to find out. What is the problem about? Janelle's Market. And what else? What did you guys say this problem is about? Oh, hold on. Pause. Come on back. I'm asking this table. What did you say this problem was about?
How many oranges Simone has?
Is that what this problem's about?
Well, what he needs. How many oranges Simone needs?
That's what we're trying to find out, right?
Yes.
So what is the problem about?
How many oranges Simone needs?
That's what we're trying to find out. So what's the problem?
How many times is
Simone and the market and the oranges. So we're talking about oranges, right? And we want to find out how many oranges Simone needs. What do we need to be able to find that out?
How many oranges they sell?
We need some numbers, right? In a minute, I'm going to reveal the numbers. I don't want you to find an answer for me yet. What I want you to do is represent the problem using the bar models. You ready? Here you go. Represent the problem using the bar models. I'm going to look for a model that represents the problem. Try using a different color. Oh, pause for a minute. Hands off and eyes up. I've got something cool to share. Did you know you can use your marker to write on the bar models?
Are we allowed to?
That might help you. Yep, you're allowed to.
We need 5 groups of these. Orange. Alright. Okay, here goes.
Let's read that first sentence. Janelle's Market sells. So what does the 8 represent?
8 represents the 8 oranges.
Okay, that are in one bag. Okay, so if we're calling this one bag, let's make sure that every bag is the same size. What does it represent in the problem?
The 5 bags. 8 oranges size. The 5 are that.
So what is this? What's this right here?
That 1 bag of oranges.
Okay, and what does the whole thing represent?
5 bags of oranges.
Okay, can you get me some labels on there and maybe write me an equation?
Well, I don't know. Can I borrow this game? Sure.
Is that a 5?
Yes.
Okay.
So what does the 5 represent?
What do you mean for oranges?
How could you represent 1 bag of oranges? Could you show me 1 bag of oranges?
Here, use this.
How many oranges are in a bag? Could you show me 1 bag of oranges? Why don't you adjust your model and show me 1 bag of oranges? I think some of your models represent the problem, and others need to be adjusted a little bit. I want to show you a couple of models that I saw, and I want us to talk about, do they represent the problem? I've seen a couple of you do this. Take a look at the screen. Give me a thumbs up or down. Does this represent the problem? Why not, Mason?
Because that would be only 13 oranges because that you've only written 8.
Oh, so if I wrote 8 on this yellow one, does that mean that they're all 8?
No.
If they're the same size and the same color, then it does. So this the yellow I'm saying represents 8. So whether I write it or not, these still also represent 8. All of my yellow size pieces, I'm calling 8. Now do you think it represents the problem? Where do you see a bag of oranges in my representation?
On the block.
On one block.
The blocks represent
So one yellow block represents,
one bag of
and what does the whole thing represent?
5 bags of oranges.
And what is 5 bags of oranges? But what is that in the problem?
8 times 5.
But what is it in the problem? Go back to, what are we trying to find out? I don't want numbers. How many oranges Simone needs? Now, I saw a couple of you do this. Does this represent the problem?
No, it's more.
Thumbs up or down? Does this represent the problem?
Yes.
This could be a little confusing, right? Because I didn't label what's what, did I? So I need to get some labels on my model. So what does this one represent? So this is 1 bag. And this is Simone's oranges. Right? Does that help?
Yes.
Am I showing Simone having 5 times as many?
Yes.
So does Simone have 5 times as many as 1 bag?
Yes.
Did you have 40 oranges? I made
If you didn't have on your model, please add an equation and write a sentence answer. I want to share something that Janari did. Janari took this model and she said, I want to figure out how many Simone actually needs. Look at this. Look at the screen. Markers down. Janari said, well, I know there's 8. And then 8 more. And then 8 more. And we've got 8 5 times. Does that help us find how many oranges Simone needs?
Yes.
I also saw a couple of you who said we could just do this. Does that work too?
Yes.
What does 5 times 8 mean? What does 5 times 8 mean?
It means
It's multiplying
8 5 times.
It has 5 groups in it.
5 sets of 8 or 5 groups of 8. We have 5 groups of 8 on our table. This is a really cool model called a multiplicative comparison model. It helps us when we need to make comparisons, to compare 2 things, to find an answer in a problem. Please clear your board. All right, and track my screen. Here's the next problem. Track the screen and read it with me. Ready? Begin. Neil and Vincent collect cans. Neil collects 10 cans. Vincent collects 3 times as many cans as Neil. What do you think it says? Do we know what we're trying to find out here? What are we trying to find out? It could be a lot of things, couldn't it?
It doesn't tell you a specific order.
Huh. So we don't really know how to answer the question yet, do we?
So we should answer it in every way we can.
Before we answer it, let's build a model. Then see if the model will help us answer the question. Okay? Go. Oh, so this shows 3 times as many cans as Neil. What do you think the question's going to ask? We're going to need that to help us, aren't we? All right, look at your classmates' models and see if they're similar. How are your 2 models the same and different? Could you add some labels to help you? Get some labels on there, and then let's compare. Whose is whose? Let's get me some names on there. Are we ready to reveal the question?
Yes.
Once I reveal the question, if you have a good model, I want you to write an equation And I want you to write a complete sentence that answers the question. I'm going to come around and look for it. You ready? Here you go. Most of you guys have an excellent model that represents the problem. You've added labels, you've drawn an equation, and you've written a sentence to answer the question. So we've got Neil and we've got Vincent. We've shown 3 times as many, but I see 2 different equations. Does it matter which one I write?
No. Yes.
I get the same answer, right? 30 cans?
Yeah, but it does.
What if I tell you it does matter? Only one of these represents the problem. Only one of them represents the problem. Which one could it be? Let's rewrite these. Let's rewrite these as groups of. So look up here. Do I have 3 groups of 10? Or 10 groups of 3? So which one represents the problem? So both of these could help us find the solution, but only one of them is representing the model you created. I want to see who can, all at once, build a model, write an equation, write a full sentence answer. Let's read it together. Ready? Begin. Mimi eats 6 times as many raisins as Mary. Mary eats 9 raisins. What's missing?
Is that how many?
There's no question, is there? We're going to come up with a question together for this one. Let's try to come up with a question that might be more challenging this time. Go ahead and build your model first and think about a question you could ask and answer. I don't need an equation yet. So this means 9 groups of 6. Does that match your representation?
6 groups and 9.
Let's adjust it. Because we don't know what's being asked yet. Come up with a good question at your tables. I'm going to pick one I really like to put up there. I heard some people say, how many raisins did Mimi eat? Is that a good question?
That's not challenging.
It's just like the ones we already asked in the first 2 problems, isn't it? What would be a more challenging one? What do you think?
What is the difference between what Mimi eats and what Mary eats?
Oh.
No, I don't want that.
Oh. That's a little tough, isn't it? What'd you guys say?
How many raisins do they have in all?
Oh, that's a good one too. I think most of you already answered the one, how many did they have in all?
Yeah.
So I'm gonna type up our question. I found one that I really like. All right, answer it. Get an equation that makes sense there. Which equation matches the problem? Which one represents your model? Some of you got it and are done. As I check you off, I'm going to put the challenge on the screen. And as I come by and say, you got it, I want you to start working on the challenge. If you're still working on this one because it's challenging, keep on working on it. And once I see that you've got it, I'll say, go ahead and start the challenge. You can work with someone at your table, build this model, and you're going to write your own word problem on your table to match it. You can work by yourself, or you can work with a partner at your table. Good. Did you represent yours yet? Today's lesson focused on multiplicative comparison. I intentionally modified the slides to focus on sense making, and my learning goal was focused on helping students to represent the word problems using bar models. As we progress through the lesson over the next few days, we'll focus more on drawing the models and connecting them to equations and more abstract representations. So today I used the try it slide to surface some misconceptions that students had about representing word problems using multiplicative comparison. I tried to look for those misconceptions in the student work and guide our discussion based on that. I wanted to make sure that we got through at least 3 problems so the students had a chance to apply the thinking from the first problem into the next one and then the next one. My goal was to see their thinking and their models become more accurate and more efficient throughout the course of the lesson.